I attended the lecture Baseball and Physics by Professor Alan Nathan from the University of Illinois. And what I'm going to be focusing on is what he talked about called the Magnus effect, which basically describes what happens to any type of projectile, really, especially in terms of like sports. You'll notice it in tennis balls, baseballs, soccer balls, especially. It's basically any derivation from a typical path of the ball due to its spin. And I drew up a picture. Sorry for my artistic talent here, but so basically this is a top-down view of a baseball pitch. So basically you can see here throwing the baseball towards the home plate, and what's happening is it's spinning counterclockwise, and when this happens, basically the Magnus force pushes it in the direction of its spin. So it's going to curve to the left because of the Magnus force, and basically why this happens is because of the spin causes the airflow around the ball to be uneven, and so on one side of the ball, basically, the air flows faster than the other side, and this causes pressure differential in the air. So this creates a force which basically pushes the ball in a certain direction, depending on whichever direction it's spinning. And you can notice this in pitches. For example, basically a curveball has some either side rotation this way or like over the top rotation, which will cause it to go either down or left and right, depending on whichever way it's spinning. And a fastball basically has a backspin on it, which causes it to kind of counteract gravity. It adds lift to the ball, so it'll go more straight than a typical kind of parabola type path. And let's see. You can also observe the Magnus effect on balls that are after they're hit. So depending on the type of swing that you put on the ball and how the ball comes off the bat, if it hits the top of the bat versus the bottom of the bat, it'll have either. If it hits the top of the bat, basically it'll have backspin on it, which will create lift, and that's why you see that's when you see pop flies, home runs, fly balls, basically. And versus if it hits the bottom of the bat, it's more directed towards the ground, and you'll see the top spin on it, which will just kind of drive it into the ground even more, basically. And so this has a great effect on the length of the ball, the length of the flight of the ball, basically. When it's hit, if there's no Magnus effect and the ball just goes straight, like if it hits at the same angle off the bat, right off the sweet spot, it'll just kind of not really have any spin on it. But the ball doesn't go nearly as far. I don't have the drawing that he had on his slide, but basically it's quite a large effect. It's noticeable hitting a home run versus just hitting a fly ball for an out. So it's quite a big difference due to this Magnus effect. And also you can notice this in many different sports. Tennis balls. You can notice this with things like paintballs, airsoft, BBs. Basically, they'll add backspin on certain BBs based off the gun design to kind of make the BB go farther, basically, because the backspin counteracts the gravity and helps keep the ball going through the air. So you can notice the Magnus effect in any number of scenarios. But I thought it was pretty interesting the way that the pitches do so many different things depending on how the ball spins. Because if it just went straight every time, it'd be a lot easier to hit. So that's why you see people striking out, I suppose.